Hello, everyone. My name is Chi Jin from Princeton University. Today, I would like to share my vision on how to unleash the power of multi-agent learning. So I want to say current generation of AI heavily relies on human-generated data. For example, the large language model actually heavily relies on the human-written text on the internet, as well as a lot of human labels on whether this article is good or not. So as shown in this picture, over the last few years, the size of models increased significantly, and also the number of data those models leverage train on also increased significantly. As predicted by this Epoch AI company, at this rate, and the number of data utilized by the language model or current existing model is going to eventually catch up with the estimated stock of human-generated data in a few years. At that rate, at that time, we'll run into the data scarcity problem where we no longer have enough human-generated data. So how are we going to leverage this problem towards generating the next generation of AI? My personal answer is to do multi-agent learning and to let the AI to self-improve himself through these multi-agent interactions. Okay. And also using the machine-generated data. So at the first glance, you may think the machine-generated data seems to have a lot lower quality than human-generated data. So I will say there are actually some mechanisms which make this possible, and a lot of them is already under development in the current stage. So I think the first mechanism to make this self-improvement possible is, I would say, you can use machine to do self-evaluation. The underlying principle between this is a lot of times it might be very difficult to write a good article, but it may not be very difficult to tell whether this article is good or bad. So in that case, we can have two agents. One you can think is more like a teacher, which will give you a reward or give you some criticism, tell you what's going wrong and how to improve. And the other agent is a student agent, which can learn from this reward and learn from this criticism. Such kind of mechanism has already been deployed in the past system called Generative Adversarial Networks in the image generation field, which achieves huge success over the past years. Currently, people also actively developing what kind of a system would make it useful for a large language model or beyond that. I would say the second mechanism is you create this competition so that you have two agents, they compete against each other. So you probably already heard this kind of story, which build a superhuman AI for Go, for StarCraft, for a lot of games. Also, you can use this kind of competitive nature to build some adversarial training network where sometimes you want to have a robust model. So you can create another agent trying to exploit weakness of the robust model so that the model kind of like learns to all the corner case and learn to be robust from those adversary. Okay, so eventually, I think only through the multi-agent learning, we can achieve so-called superhuman performance. That is, if we always learn from human label data, most likely we will just basically learning from humans. And only if we can like learn by ourselves, improve by the agent itself, eventually they can beat humans significantly. I think this has already been shown in like chess, in Go, in like strategic games like StarCraft, also in poker. But there are also a lot of things which are still below the bar of human, and there are a lot of room to improve that include a lot of like mathematical reasoning and also the coding tasks. Okay. So we talk about all those tasks and how we're gonna achieve those tasks, or what are the intermediate steps to do. I would say first we can start from the foundations of this multi-agent learning. Like we can first talk about what kind of concepts, solution concepts we would like to find. Like a lot of past fundamentals based on the game theory. So they always talk about equilibrium, including Nash equilibrium, correlated equilibrium. Also, like you have sequential games, like you have Stackelberg equilibrium. But I would also like to say there are a lot of things happens in practice which probably require things beyond equilibrium. Like you want to be rationalizable in the sense you don't ever want to play any like dominated actions. Or a lot of times the games are equal or symmetric, so they are fair. So you would like to achieve some equal share, which all those kind of goal is a little bit independent of each other. And how we're gonna achieve all of them, or how we're gonna achieve some of them, is kind of like a very important question, or how we define what is the solution concepts we want to find. And the second thing I would like to say is also the game design or the mechanism design, like how agents interact with each other, play with each other. This also play a critical role in like developing those multi-agent systems. For example, in the GAN, which like we mentioned earlier, we do self-critiques or self-play. Those are different mechanisms. You can either have a lot of agents cooperating with each other. You can also have agents competing with each other, and you're going to learn different perspectives from them. And you can also have tons of agents together, and so they kind of like trying to help each other, and you can define new ways, new interactions, so that we can try a lot of different things. So what kind of game mechanism would help agents improve the most? And finally, I would also to say, in order to move that, we of course need a lot of benchmarks, which we create a lot of data sets, and so that we can evaluate those multi-agent system on. And we also need to develop a lot of multi-agent algorithms, which we can combine with reinforcement learning, or we can combine with large language model, and with the game algorithm like fictitious play, cell play, a lot of different things, and which to define to develop an efficient multi-agent algorithm. And this concludes my talk. Thanks.